analysis of continuous beam with support settlement. So analysis of a continuous beam with support settlement will observe. We have already seen this when a fixed beam is there, when one end is having a support settlement by delta, then the additional moment that is created in the beam is nothing but 6 EA delta by L square. And this is also 6 EA delta by L square. So you can observe here when the support settlement is happening in the with respect to left support, when the downward support B is coming down, then you can observe anti-clockwise direction. The fixed moments are developed. So when this anti-clockwise is there, you can give a sign convention of negative. As per moment distribution method, the sign convention is anti-clockwise is negative, clockwise is positive. Now coming to here, when a support B rises with respect to support A, that is left support is down compared to right support. So in this case, the additional moment developed is nothing but it will be in the clockwise direction. So this clockwise moment is nothing but 6 EA delta by L square. So MFAB and MFBA here they will be positive, and which is equal to 6 EA delta by L square. So here in this case, here this is MFAB is equal to MFBA is equal to minus 6A delta by L square. So whereas this one is plus 6A delta by L square, that we need to understand regarding the analysis of continuous beam with support settlement. Just note all these points quickly. So now we will go to one problem and we will try to analyze the given problem by considering a support got settled. So note on the problem. Analysis of a continuous beam So in this class, we are observing analyze the given beam shown in figure with moment distribution method. So here, draw the beam. A continuous beam is given. Here, a overhanging portion is there. And on the BC span, a UDL is acting. And the value of UDL is 15 kilonewton per meter. A point load is acting here, which is 70 kilonewtons. And this is 4 meters, this is 2 meters, and this is A. Now it is given that support B sinks by 10 mm. Support B sinks by 10 mm. E is equal to the value of Young's modulus of the material for the entire section is given, which is 200 kilonewton per mm square. Moment of inertia is given as 4000 into 10 power 4 mm power 4. So they are asking us to draw BMB, and SFD. So this is the given problem. So with the help of moment distribution method, this problem is to be solved. So now just understand here, first of all, we need to calculate the fixed end moments due to loading. Here we should understand, here there are two things are there. The fixed end moments due to loading is one thing, and due to sinking of the support is second one. So we need to calculate both the things. So in the first one, I will keep side heading of writing down the values of fixed end moments due to loading. So due to loading is for the given loading, when there is a point load, when there is a UDL, so corresponding to that, we need to write down the fixed end moments. So this is MFAB is equal to minus WAB square by L square. So we already know when a concentrated load is acting, and this is 70, A is 4 into 2 square by 6 square. So tell me this value, 31.11 kilonewton meter, and MFBA is plus WA square B by L square, which is plus 70 into 4 square into 2 by 6 square, plus BC length is not mentioned. Okay, I will mention the BC length also. This is 4 meters. Equal to minus WL square by 12 minus 15 into 4 square by 12. So minus, so what is this value?
20.
Minus 20.
Minus 20 kilonewton meter. MFCB is plus WL square by 12. So plus 15 into 4 square by 12, which is plus 20 kilonewton meter. Okay, now observe with this MFCB is calculated. Now you can see here overhanging portion is there. This overhanging portion, here the resistance will be given here. This directly we can write it as MCD, which is nothing but now this deflection will be like this. So 10 into 1 is the moment at C. So the support moment MCD is equal to, I will not write it as fixed one. Why? Because this is the final moment only. So MCD is equal to minus 10 kilonewton meter. So these are the fixed end moments due to loading. Now next one is fixed end moments due to.
Sir, clockwise, yes, sir.
Now just understand here, in this case, your CD is overhanging portion. At this one, the point load, it is trying to deflect like this. So the moment formed here, it is 10 into 1, 10 kilonewton meter. But support, what it will do, it will resist the moment in this direction. So the resisting moment is nothing but it is in the anti-clockwise direction. So that's why MCD will be minus 10 into 1, minus 10 kilonewton meter. Is it clear? Saira, now just see this one. See this one. Here, your support is here. Your beam is trying to reflect like this, but the purpose of the support is to give resistance. So when it tries to give the resistance, so that will be in the anti-clockwise direction, minus 10 kilonewton meter. Now coming to here, just you can mute yourself. Now let me continue to the next one. Here fixed end moments due to support settlement. So next continue. Fixed end moments due to support settlement. So in this, the first point is we need to first of all observe which support is sinking. So support B settles by 10 mm. So delta B is nothing but minus sorry, 0.010 meters. So convert in terms of meters. Why? Because everything, length is in meters, everything should be converted in terms of meters. Now coming to here EI is to be calculated. So EI is nothing but, just see here, E is nothing but 200 into 10 cube Newton per mm square. So EI is nothing but 200 into 10 cube into 4000 into 10 power 4. So if you observe, the units of this one are Newton per mm square and this is mm power 4. You will get the answer in terms of, now tell me what is the answer here? Is it okay? Just check it. This is 10 power 2 into 10 power 5, 4 into 10 power 7, 5 plus 7, 12. So 8 into 10 power 12 Newton mm square. Now I will convert this in terms of kilonewton meter square. Why? Because all the moments and everything, they are in kilonewtons and length is in moment meters. So 8 into 10 power 12 by 1 Newton is nothing but the 1000 kilonewtons by 1000 into 1 mm is nothing but 10 cube whole square. Why? Because this is in terms of meter square. So that is 8 into 10 cube kilonewton meter square. So that is the value. EI is nothing but 8 into 10 cube kilonewton meter square. So now write down this here. EI is equal to 8 into 10 cube kilonewton meter square. So which is called as flexural rigidity. Now coming to span AB. First of all, take span AB. So in the span AB, this is your span. I am considering this is A point, this is B point. Now what happens here, there is a support settlement with respect to B is settling. So when B is settling and the value is nothing but 0.01 meters. So just see this one, this is the direction. How you can remember this direction? Just understand, when a support settles here, what happens is it tries to bend like this. But what it tries to do is, due to the fixity at this point, this here the support cannot go like this. So the elastic curve of the member or deflection profile will not be like this. Here, that's why it will be converted like this. So how this is happening? Due to the support reaction at this point, so which is trying to make linear, or which is trying to make the rotation 0. Here also it is trying to go like this, but it makes the rotation 0 at this point. That's why this is the direction like this, which is anti-clockwise. So we know that anti-clockwise moments are negative. MFAB is equal to minus 6EI delta by L square. So what is the length of this span here, which is 6 meters. So minus 6 into 8 into 10 cube into delta is 0.01 by 6 square. So which will give you the fixed end moments. So similarly, calculate for MFBA also. MFBA is also to be calculated for span AB, which is also minus 6EI delta by L square. Whereas coming to span BC, in the span BC, what is happening now in this? B is there, C is like this. So support B is settling like this. Support B settles like this. So which is a moment like this. Now see in this case, the beam tries to deflect like this, but the support at this point, it makes the rotation 0 as fixity is there. Here also the rotation should be 0. That's why clockwise moments are developed. So these clockwise moments are MFBC is Now, according to the length here, which is clockwise 6 EI delta by L square. L is 4 here. 6 EI value is already known. You can write down the EI value. So 6 into 8 into 10 cube into 0.01 by 4 square. This is MFBC. MFCB will also be the same thing, and write down this distribution factors. So just write down this as distribution factors. So the distribution factors are calculated at the joint. So this is joint B. At joint B, if you observe, the number is there. Hello. Sree. Sree చెప్తాను నేను క్లాస్లో ఉన్నానమ్మా ఇప్పుడు ఆఫ్టర్ 12 అనుకోవచ్చు. So now here joint B is there. At this joint B, now you can observe that a span is of AB is there here, which is a fixed one, and C is a continuous one. So obviously in this one, if you observe the relative stiffnesses of the members, this relative stiffness of the members I is constant. There is no change in the I value, and this is length is 6 meters that is given. So the relative stiffness of member BA will become as I by L. And whereas coming to here, this is 4 meters and moment of inertia is I only, and this is for KBC is equal to I by L. And you have to ask me, this is a support which is having overhanging, and where the overhanging is there, that's why you can consider it as a continuous support. So that's why there is no reduction in the stiffness, relative stiffness of the member. So when you write down the distribution factor for BA, which is nothing but relative stiffness of BA by summation of relative stiffness at the joint, KBA plus KBC. There are only 2 members that are meeting at joint B. So which is I by 6. This is I by 6 plus I by 4. So you can tell me what is this value. DFBA. Do it and tell me the value. Whereas DFBC is equal to KBC by KBA plus KBC. So this will be I by 4 by I by 6 plus I by 4. So 4, second one is 0.6. You can observe when you add both the things, DFBA plus DFBC, they are making to 1. So we should remember the distribution factor at a joint is equal to 1. Now when these distribution factors are completed, we will go to the preparing the tabular form for the given beam. So this is our beam. So this is our beam. Just once again I will draw the beam. Net moments. Just make it as net moments and add everything here minus. This is 44.44 kilonewton meter, and this fan value is plus 62.22 minus 13.33. The only difference when the support settlement is there, this fixed end moments due to support settlement, they are to be added and to the loading, fixed end moments due to loading, and calculate the net moments. So when you calculate the net moments, then you can continue the problem. So tell me here, what is the value here? 48.89. And this is plus 50, this is minus 10. So remember here, now what we should do. The next thing is we have to balance C here. Just remember this one. Many of you might have thought that here this is plus 50, this is minus 10. So take the difference and balance these things. No, we should not balance here. We have to balance C, but what we have to make is, we have to make the value as plus 10 here. Plus 10 here. So to make it plus 10, why? Because due to this overhanging at MCD, the moment is minus 10. This is fixed. This is like minus 10, you have to get it. To get minus 10 and to make the joint condition satisfied, here we are balancing balance C. So while you are balancing C, what are the steps you need to follow? So to here balance C, and this value will be apply a moment of minus 40. So when you are applying a moment of minus 40, so what would be this value? Plus 50 minus 40, then that will be plus 10. So plus 10 and minus 10, the joint condition is satisfied. The joint condition is satisfied. That means here MCB, the joint condition that is to be satisfied as MCB plus MCD is equal to 0. And what is the value of MCD? Minus 10. So MCB should be equal to, this is minus 10 is equal to 0. So MCB is equal to plus 10 kilonewton meter. To obtain plus 10, here already plus 50 is there. If I make minus 40, then obviously the moment, final end moment will be plus 10 only. When I am balancing C, carryover moment will be there. So the carryover moment is to be to the nearest one for the far end, which is minus 40 by 2. Now write down the net moments. Write down net moments. So when you are writing the net moments, so this is plus 10, this is minus 10, here this is minus 44.44, this is 48.89, this is minus 20 plus 10, minus 10. So now you have to balance B. So while balancing B, what is that one? So at this joint, what is the value you are getting? 38.89, which is positive. So take minus 38.89 and multiply with the distribution factors. 0.6 into minus 38.89. Now you have to carry over moment. When you are balancing, just remember carry over moment should be there. This is half of that one by 2. And from here to here, remember it will not be there. Why? Because already the balancing is completed for C, and you should not once again send it. So this is final end moments. So after completing these final end moments, so just add everything, minus 44.44 into minus that is 0.4 into minus 38.89 by 2. So the final end moments are to be obtained. And this is plus 10, this is minus 10. So you can check out these values and see whether the joint condition is satisfied or not at B as well as at C. So you can write down MAB is equal to MBA is equal to MBC is equal to MCB is equal to plus 10 kilonewton meter. MCD is minus 10 kilonewton meter. And check these values whether you are able to get the values or not. Minus 48 point, what is this value here? Which one? Minus, if you write minus 52.218, what is that one? MAB or MBA? Which one I have to write here? AB. So minus 52.22 kilonewton meter, which is MAB. And what is MBA? What is MBA value? 33.33. Yes, 33.34. You people should be quick. 33.34 kilonewton meter. MBC. MBC minus 33.34. So try to draw shear force diagram and bending moment diagram. Just check it whether you are able to draw the shear force diagram and bending moment diagram or not.